Good day, everyone. You're welcome to Bonster channel. We are still on quadratic equation, and today I'll be showing you another method you can use in solving quadratic equation, and it is called completing the square method. I'll be teaching you how you can use completing the square method. In our last video, we talked about factorization method, and today we'll be talking about completing the square method. Let's say we have an equation that is 2x squared plus 7x plus 6 equals 0. And you are asked to solve this using completing the square method. Please, I'd like you to listen to the step, because if you miss just one step in this completing the square method, you might get all your answer wrong. So please, I want you to listen attentively. Find a place to relax. So let's go. If you're given a question like this that says 2x squared plus 7x plus 6 equals 0, the first thing you have to make sure of is that the coefficient of x squared must not be more than 1. It must not be greater than 1. It must always be equals to 1. Not less than 1, nor more than 1. So you must make sure that the coefficient of x squared here is 1. So how do you do that? You can write this equation by dividing each and every terms you have in this equation by the coefficient of x squared. And by that, you will be deriving at this divided by 2 divided by 2 divided by 2 divided by 2 will be giving you x squared. Can you see now the coefficient of x squared is now 1? That is, the number that comes before x squared must not be more than 1. Plus, you have 7 over 2x, and 6 divided by 2 gives you 3. Everything equals 0. 0 divided by 2 will give you 0. That is the first step you have to take. The first step is what? Okay, make sure the coefficient of x squared is 1. And by doing that, you go to the next step. The next step is that you look for half of the coefficient of x. Note, this is not x squared this time around, but x. The first one we did is x squared. Now we'll be dealing with the coefficient of x. And in this equation now, the coefficient of x is 7 over 2, which is 7 divided by 2. And if you are looking for the half of coefficient of x here, that means you'll be dividing 7 over 2 by 2, which means if you are to divide 7 over 2 by 2, if you are to divide 7 over 2 by 2, you'll be having 7 over 2 multiplied by 1 over 2, which equals to 7 over 4, which equals to 7 over 4. So this is the half of coefficient of x. This is the half of coefficient of x, which is the next step you have to take. And the third step now is that you must square the coefficient that you have halved. That is, the answer you get here, you square it. That is, you will be having 7 over 4, then you square it. That's the third step. Take note, the first step is to make sure that the coefficient of x squared is 1, and we do that by dividing 2 by 2. The second one is that we should find the half of the coefficient of x, not x squared, but x. And also, the half you've gotten, you are to find the square of it. That is, you have to square it, which we have 7 over 4 squared. What do you think you're doing with that? Let's go on. So you'll be adding this to the equation. But before you add it, there's one more thing you have to do, which will be your fourth step. That is, from your equation, you have your equation to be x squared plus 7 over 2x plus 3 to be equals to 0. You see this plus 3 that you have here, which is the constant, you have to transfer it to the other side. So for you to transfer it to the other side, you'll be having x squared plus 7 over 2x equals to minus 3. Equals to minus 3. When it crosses to the other side, it turns to negative. It has minus 3. So the next thing now you do is you have to add this equation to both sides of the equation. You have to add this square of the half of the coefficient of x to both sides of the equation. And by that, you will be having x squared plus 7 over 2x plus 7 over 4, then you square, equals to minus 3 plus 7 over 4, then you have square. Can you see? I'm adding it to both sides of the equation. So adding it to both sides of the equation, what you have here is what we call a perfect square. What do I mean by perfect square? I showed you earlier what a perfect square is. A perfect square is an example of saying x squared, x plus 3 and x plus 3. This is an example of perfect square whereby the terms you have in each cases are the same. And you can simply rewrite this by saying x plus 3 square. That is a perfect square. If you open this, you'll be having the same thing as if you open this. So this you're seeing here also is a perfect square. I'll be dropping another video to test the theory if it is a perfect square or not. So please endeavor to on your notification bell and make sure you subscribe, so immediately I drop the video you'll be notified, and you can also watch to clarify any confusion you might be having. So let's go on. So the next thing you do now is you pick the terms that you'll be having for the perfect square, which are x squared plus 7 over 4. So instead of me just using one square, since I said it's perfect square, I will just put everything into the bracket together and I will square everything while solving the other side of the equation. The other side of the equation gives me minus 3 plus 7 squared gives me 49 over 16. I'll be having 49 over 16. I can proceed from here by saying x plus 7 over 4, everything square, will be equals to, let me find this. You have the LCM to be 16. 1 in 16 gives me 16. 16 times minus 3, that gives me minus 48. Yes, plus 16 in 16 gives me 1. 1 times 49 gives me 49. So I'll be having x plus 7 over 4 squared to be equals to 1 over 16. Here I am now. So the next thing I'm going to do now is I have to eliminate this square from this side and transfer it to the other side. That means I have to introduce square root to this equation. So I'll introduce square root to both sides of the equation. And if I introduce square root to both sides of the equation, that means this square, we cancel this square root. I'll be left with 8 plus 7 over 4 to be equals to, the square root of 1 over 16 gives us 1 over 4. Square root of 1 is 1 and square root of 16 is 4. So from here now, but take note, there is one thing I would like you to note. If you are looking for square root of any number, the square root of any number gives you two numbers. Square root of let me say square root of 4 gives me plus or minus 2, because 2 times 2 will give me 4, and also minus 2 times minus 2 also gives me 4. That means you can have two values for the square root of a positive number, which means what I'll be having here is not just 1 over 4 plus, but I'll be having plus or minus 1 over 4. I'll be having plus or minus 1 over 4. So the next thing to do now is to transfer this to the other side, and transferring it to the other side, I'll be having x plus 7 over, I'm transferring it to the other side, so I don't need to rewrite it. I'll be having x equals to plus or minus 1 over 4. Then this turns to minus 7 over 4. For clarity, I can have this equation written as x to be equals to minus 1 over 4 minus 7 over 4, or I can have it to be x to be equals to 1 over 4, which is the positive one, minus 7 over 4. In case of the first one, where x equals to minus 1 over 4, where x equals to minus 1 over 4 minus 7 over 4, I have my LCM to be 4. 4 in 4, 1. 1 times 1 gives me minus 1. Then 4 in 4, 1. 1 times 7 gives me minus 7. So I'll be having it to be minus 8 over 4, which is equals to what? Yeah, 4 here 1, 4 here 2, which is minus 2. That's the first value. And the second value is when 1 over 4 is positive, minus 7 over 4. So my LCM here is also 4. 4 in 4, 1. 1 times 1 gives me 1. 4 in 4, 1. 1 times 7 gives me 7. That's minus 7. So I'll be having it to be minus 6 over 4. 2 here, 3, 2 here, 2, which equals to minus 3 over 2. Which means the two possible values I'll be having for this equation now is minus 2 or minus 3 over 2. Imagine you're asked to factorize this. How will you be able to get the answer easily? So let me give you another example on factorization method, on completing the square method, and we can move forward to another method after the example. Here's another example, and I want us to use completing the square method to solve this. So let's go on. Remember, the first thing we have to do is to make sure that the coefficient of x squared is equals to 1. And in this question, you don't need to stress yourself. You already have the coefficient of x squared to be 1. So we proceed to the second step. And the second step says we should find the half of the coefficient of x. And the coefficient of x here is -6. Take note, you have to take along the sign with it. Consider the sign, it is also part of it. So you have it to be -6, and half of it will give us what? Yes, -3. -3, that's the second step. We have gotten the half of the coefficient of x. And the third step now is to square it. You have to square the half of the coefficient of x that you've gotten. So if I'm to square it, I'll have -3 square. -3 square. And the next thing is to rewrite this equation by transferring this constant to the other side. So I'll be having x squared minus 6s to be equals to -5, which will be my fourth step. And the next step is to add this half of coefficient of x to both sides. So if I'm adding it, I'll be having x squared. Sorry, let me come here because of space. So I'll be having x squared minus 6x plus, I said I'm adding it, -3 squared to be equals to -5 plus -3 squared. This is what I'm having. So if I'm to solve this, I'll be having, remember I said this is an example of perfect square. That is, if you pick this and this alone and you're trying to expand it, you'll be having the whole equation. So I'll be having x. Remember, if I said remember, I'm bringing this, so it will be x minus 3, everything square, to be equals to, then I'm to expand this to be -5 plus 9. How do I got that? -3 square is -3 times -3 gives me +3, and positive times positive gives me positive. So I don't need to stress myself on that. I'll be having x minus 3 squared to be equals to what? Yeah, 4. The answer is 4. So I'll have to transfer this square to the other side by introducing the square root. And if I introduce square root, the square cancels square root. I'm left with x minus 3 to be equals to the square root of 4 is not just 2. Remember the last example, the first example we did. The square root of 4 is not just 2, but what? Yeah, plus or minus 2. Sorry, plus or minus 2. It is plus or minus 2. Now I have to transfer this to the other side. I'll be having x equals to plus or minus 2 plus 3. So my two values will be x to be equals to -2 plus 3, or x equals to 2 plus 3. That is when 2 is negative and when 2 is positive. And this gives me what? 1. Or your x to be equals to what? Yes, 5. So I have my x to be either 5 or 1. And you can try to use factorization method for this equation. It also work, and you can use it to cross check if your answer is really correct. If you are to factorize this, you have to look for two values. When multiplied together will give you 5, and when add together will give you what? Yes, -6. And there are only two possible values for that. You have to look for factors of 5 first. The factors of 5 that you'll be having is 1 times 5, and also what? 5 times 1. It's still the same thing, but it can either be plus 5 plus 1, or what? Yes, -5 minus 1. If you multiply these two numbers together, you'll be having this. But which one of them can you add together to have -6? And it is -5 minus 1. If you introduce it to the equation, your equation becomes x squared. You have to be -5x minus x plus 5 to be equals to 0. Then if I'm to factorize this, what's common to both is x. I'm left with x minus 5. And what's common both here is just 1. But this time I won't be using 1, because I need to make sure this 5 become negative also. So I'll be dividing it by -1, which means -1 is common to both of them. And this x becomes positive, and this one becomes negative. And I have it to be x minus 5, x minus 1. Everything equals 0. So x minus 5 equals 0, or x minus 1 equals 0. Your x equals to 5, or your x equals to 1. This is just a way you can use to cross check if you are correct as long as you are able to factorize the same question you are using the completing the square method for. So thank you for watching this video from the beginning. Our next video will be on the next method, which will be, yes, general formula, the quadratic formula, and I'll be teaching you how you can derive the quadratic formula yourself, because the completing the square method is what we also use in deriving the quadratic formula. So don't forget to on your notification bell and subscribe, so immediately I drop the video you'll be notified. Don't forget to like this video and share. Thank you very much.